So, Miko, can you tell me about yourself and your role at Silicon Labs for those who don't know?
Hi, my name is Miko. I'm a senior product line director at Silicon Labs. I'm responsible for commercial business at Silicon Labs, and what commercial covers is various applications from automotive applications to anything we do in commercial smart buildings, enterprise IoT, and also asset tracking, which kind of fits our topic today.
Sounds good. Speaking of our topic today, I kind of wanted to get just a basic landscape of the overall, challenges or needs that you believe are surrounding connected healthcare today. What's it looking like?
So if we kind of specifically talk about the asset tracking piece, as connected healthcare can things from medical devices worn by consumers for glucose monitoring or insulin delivery to heart rate monitoring. That's kind of very different application versus what we see in the kind of clinical asset tracking space. And asset tracking, it's essentially about becoming more efficient, either knowing, where your people are, where they're spending their time. In the commercial healthcare space, it might be tracking patients, making somebody falls over, knowing where they are so you can send help. But it's also about tracking expensive equipment. As I'm sure we can all imagine, hospitals are full of expensive equipment, and they get lost in hospitals, and that has led to a situation where people do spend extra investment in having more equipment than they basically need, so they spend less time finding them. So when we talk about real-time asset tracking solutions in these spaces, it's essentially becoming more efficient by having less expensive equipment and spending less doctors and nurses time on finding where people or that equipment are.
Sounds good. You kind of touched on my next question a little bit, but can you walk me through the radio vision solution? How does this battery-powered AI-enabled Bluetooth doorway choke point system and the real-time location system, how does it look and operate for the medical professionals that are using it?
So, of course, Animate is probably the more expert in explaining what their product is.
Okay.
Usually how these solutions work is, you tag the assets, that you want to track. So you either attach a small asset tag if it's an equipment.
Mhm.
If it's a person you're tracking, it might be something you wear like a badge or a, wristband. And as those things move around, they need to be battery powered. They need to be able to transmit their location or some RF signals that the infrastructure can then use to determine their location. And they need to have years of lifetime, as we don't want changing batteries frequently. Consumes people time, and we want to reduce the amount of environmental waste we produce. So the basic concept is whatever you want to track, you need to tag it somehow with you know almost in every case a wireless device transmitting RF signals being battery powered. Now, to be able to locate your assets where they are, you're going to need some infrastructure in place. Typically, this infrastructure, it can be portable devices, handset scanners that are used by people. But in case of Animate Wireless, they're actually what we call locators or access points. So, piece of hardware that typically gets installed into a room in a hospital. In hospitals, of course, multiple rooms, and they're responsible of, listening where these tags are and determining their location. And then typically that information gets transported to, cloud infrastructure, and then users will have some sort of dashboards, mobile applications, and so on to see where those assets are and go and find them as efficiently as possible. One
Oh,
unique thing about this solution is the infrastructure is battery powered. Some of that infrastructure is mains powered, Ethernet connected, which makes installation a lot more costly. because in many cases, when this infrastructure gets deployed, the largest cost is essentially pulling wires. So making sure there's electricity available, making sure there's Ethernet available, and with wireless infrastructure and our battery-powered wireless infrastructure, you can reduce the installation cost significantly and remove that cabling aspect out of it, and that reduces the investment cost to deploy these solutions, which then translates to far faster return of investment for the hospitals. So they're more, let's say, they can more easily deploy these solutions because the installation cost is reduced.
So let's talk a little bit more about the Silicon Labs SoCs, I think the BG2022 and the MG26. How do SoCs like that support medical IoT compared to maybe earlier wireless platforms?
So there's kind of this solution, as I explained, it typically consists of two solutions. There's the asset and the tag you want to track, and then there's some infrastructure responsible for tracking. So BT22 is used on the tech side of things. BT22 is our lowest power, let's say most affordable, most optimized device for these asset tags, which really enable affordable asset tags to be built, which can run years on coin cell batteries. The MT26, it's a higher end device that's used on the infrastructure side. It's essentially responsible for discovering the tags. And then there's the algorithms that compute the location of those tags. And, you need more processing. That's why, for example, they use our AI accelerator, because these positioning algorithms are mathematically complex. And require more resources. So that's where the MT26 excels. It has the right resources, the memory footprint, the AI accelerator to run the computational algorithms needed to discover the asset tags. So that's kind of the high-level overview how the Silicon Lab solutions play into this.
Mhm. And what made Bluetooth, I guess, the right foundation for this solution versus, other wireless technologies, in your opinion?
So Bluetooth is in a great position for this application. There's multiple reasons for it. Bluetooth is such a widespread technology. It's easily accessible by people. People do understand very well how Bluetooth works. It's extremely low power, supporting the battery asset tags that need to run for years. And Bluetooth has some unique capabilities to when it comes to these real-time location solutions. What we kind of tend to call the locationing toolbox for Bluetooth, and it probably has three major things you can do. For the simplest location solutions, the Bluetooth devices just broadcast their presence. So it's basically like shouting out, "Hey, I'm over here." And you can detect the signal strength from that broadcast. Based on that, you can do rough estimations where the devices are. You can't get to accurate position, but not every application needs accurate position. Now, if you go to these hospital applications, one key performance indicator over there is you need to at least to get to a reliable room level accuracy. So when you send a nurse out to find a patient or find a piece of equipment, you want them to get to the correct room, not the room next to you. So you need something which is more accurate than the pure signal strength based solution. And the second thing in the Bluetooth toolbox is something called angle of arrival and angle of departure technology, which is utilized in this solution. And with this technology, you can get the direction of the signal, so from which direction the signal comes from. And with that information, you can get to a more accurate position than just something 10 meters away or 5 meters away. In the very recent developments of Bluetooth, and these the solutions are only being deployed as we, or let's say developed as we speak. The third tool in the Bluetooth toolbox is something called channel sounding. What channel sounding gives on top of the previous solutions is accurate distance measurement.
Mhm.
So then you can measure distance between two Bluetooth devices, something which has not been possible with Bluetooth before the introduction of channel sounding. And that can furthermore enhance these positioning solutions, because now you can get three things. You can get rough presence based on signal strength. You can get the direction of the signal, where it comes from, and then channel sounding can add distance measurement, on top of that. So not many other technologies have kind of these tools, or many wireless technologies have these tools in their toolbox. So I think that makes Bluetooth quite unique for applications like this.
Sounds great. I kind of want to talk about the collaboration between Labs and Emanate. So, and kind of how it began. How did the architecture or how did the hardware software co-design process between the two companies, shape the final system architecture?
So I wasn't personally involved in the let's say the technical details of the
Mhm.
cooperation. Usually how this works with our customers, they see us as the wireless experts.
Yeah.
Of course, many of our customers are wireless experts themselves, but usually cooperations like it, start with technical consultation. We explain, to our partners and customers, what are the possibilities with the technologies we do. What are the limitations. What we think is possible. What may not be possible, and then we try and figure out, does that fit to the use case our customers and partners are trying to accomplish. So it starts as this typical consultation process where we both try to find what works, what doesn't. In the when the development starts, we do help customers with various aspects of their design. We can review their hardware designs. Some cases we do performance testing for them, measure RF performance. In the case of these location technologies, we can help them, measuring, how accurate position they're getting, or how accurate the distance measurement is they're trying to accomplish, and give them some guidance, how to improve things if needed for their application. And the same happens also on the software side. Many times we enhance our software solutions, or work together with our customers to add features and functionality needed by their application. As we tend to be experts on implementing protocols like Bluetooth, or even higher level applications like positioning algorithms on top of the Bluetooth communication. So it's a multi-stage collaborative process, starting from how to realize the use case, and then moving on, how do we get through the development phase, and start helping our customers having ready products on the market.
Right. So, I guess in your opinion, how do you foresee this innovation of real-time location and automation in healthcare maybe evolving over the next few years, just in your opinion?
But real-time location, it's a hot topic these days. Everybody wants to improve operations, become more efficient, reduce expenses in capex, and not investing into more equipment than they need. However, especially when it comes to indoor location, I don't think that there's not necessarily a holy grail solution yet. There's
Mhm.
multiple solutions, from Bluetooth to ultra wideband to millimeter wave radars, and each of them have pros and cons. One thing which is for sure, all these technologies keep improving as we move forward. Like I explained previously, we're just adding this channel sounding technology in the Bluetooth, which gives another capability and with distance measurement to bring more accuracy, or new types of use cases for locationing. So that's that development I see continuing and improving as we go forward. Also in the wireless space, you know, uh, we do see, gradual improvements with all these technologies. It's either, our performance becoming better, power consumption going down, or, the technology becoming more and more affordable, for these types of applications. So, multiple developments on multiple fronts, I would say.
I think that's all the questions I have for you, Miko. But as always, I'd like to know if there's anything I might have missed or anything else you'd like to add about this collaboration between Silicon Labs and Emanate, about the radio vision solution or about the SoCs that you guys are using.
Well, I think we covered the most important topics I wanted to discuss.
Mhm.
As we, as like I said, with many of our customers and partners, it's a collaborative way of working. We, as time moves forward, we probably see an evolution in these systems. Improved accuracy, increased battery life. Or other advancements as our customers learn what the market needs, and as we educate them, what's possible with technology and the developments and evolvements we see over there. So I'm sure there's going to be more we hear from this or similar applications in similar spaces.
Sounds great. Thank you, Miko.
All right, thank you.